All right. So before we jump into just doing review and me fielding questions from you guys, a couple things I wanted to mention. So this will be the last recording. The things that are still out there and available if you haven't done them yet already, that module 12 and 13 quiz, then those 3 participation quizzes from this week, all due by the end of the day today, right? Thursday the 31st. So make sure you get those completed. Canvas should update everything. Once you've completed those, it's currently set to where it drops your lowest module reading, drops your lowest 4 participation quizzes, and it's dropping your 2 lowest quiz scores. So your grades in those categories, you should all see are going to be what your final grades in those categories will be. You then have your first, your 2 midterms, and then I've got the final actually published, although you can't access it until tomorrow. So I've extended that window just a little bit just to give people some more flexibility. I know people are, traveling time zones. So 10:30 tomorrow morning, it'll set to be released, so you can access it at 10:30 up until 3:30 tomorrow. So that's the kind of time when it will be open. Once you start, it'll have an hour and 30 minutes to complete it. It requires that lockdown browser, so whatever device you're using, make sure you've got that downloaded. I would suggest using the one that you used for the second midterm just to make sure you know that it was working there. I will be in my office and keep an eye on things throughout that time period. So if you're having any issues, please let me know as soon as possible. We can, if there's any technical issues, although I didn't really have any in the last one, so that hopefully things kind of work similar for this final exam. You've got your practice exam, final exam you can kind of use as a kind of a study tool. All the old practice problems would be good things to be able to review before you sit down to take that final as well. And I think I've got it set to be released. So Saturday morning at like 10 or something, I'll have it set so you can then kind of review the final, just making sure everyone gets that in. You can review the answers. I'll kind of get grades finalized at some point on Saturday. But once you complete it, I'll have everything set up so it should be accurately kind of giving you your grade anyways. It'll kind of weight that final according to the syllabus. The only other thing I wanted to mention was I put up an announcement. I think I can't remember if I mentioned this section yesterday, but if you have some time by the end of the day today, I know you're probably getting tired of getting emails about this, but it helps me out if you fill out that online course questionnaire. So this is the first time I've taught this specific course in the summer, at least here at IU. Things a little bit differently on online courses. So I like to get some feedback, things that worked, things that didn't work, thinking about how I could kind of change things moving forward. So if you don't mind filling that out, I greatly appreciate it. I understand you've got a lot of other stuff going on. I would say, prioritize the final exam and studying for that before you do the online questionnaire. But that should kind of cover everything. So leads us right into the final exam, which will be tomorrow. And one thing I want to mention, so that it's open under that time block. However, it closes at 3:30. So if you do want to take it and you want it the full hour and 30 minutes, you need to start no later than 2 o'clock, which is when our normal class would start anyways. Okay. If you want to start it early, kind of give you a little more flexibility early on in the day, you can go ahead and kind of start it in any time in that time block. And once you start, you'll have an hour and 30 minutes. Okay. All right, I think that should cover all of the little housekeeping stuff. We'll kind of come down here. I've got the practice final open, but if you have any other questions or old practice problems or something that didn't show up that you think you might have a question on that didn't show up in this practice final, now is the time to ask it. And you can use the chat or you can use kind of, audio. 17 and 18, those are good ones to ask. Where are we at? Here we go. All right, so let's say I gave you something like this, right? And I'll kind of go through that next. So, and actually I'll add some stuff into problems 1 and 2. I wanted to get there sometime today. So 17 and 18, we're thinking about, this kind of hits 2 things. One is which is looking at game theory, but also thinking about how we would make this decision for single price monopolists. So I've given you the demand curve by essentially giving you the price and quantity, okay? I also gave you total revenue. Now, if I didn't, so let's say, I'm just going to copy this real quick and do it in Excel just to make it kind of easy. So we're thinking about two firms with constant marginal cost of 60 acting together as though they're a duopoly. If they hold true to the agreement, or sorry, they are a duopoly, they're acting together as a monopoly. If they hold true to that agreement, what's the price and how much would each firm produce? So if we go to Excel, I'm just going to copy and paste this in here so I can do the math without kind of doing it all by hand. But where did this total revenue column come from? In fact, I could on the exam only give you the demand curve, in which case, how would you find the total revenue that a monopolist would earn? Well, if they're acting together as a monopolist, it's simply total revenue is price times quantity. So these values are the exact same values as what we had before in that total revenue column. Okay. Now, what are we going to need in order to determine where the monopolist would kind of produce? Well, it's where marginal revenue is equal to marginal cost. So we had this constant marginal cost of 60, right? So visually, kind of give a visual to go along with this as we're looking at this table. We're looking at, we've got this demand curve, right? Here's quantity, here's price, started out at 100, okay? We are thinking about, we've got this constant marginal cost of 60. Now we know that if they act together as a monopolist, they're going to make decisions based off a twice as steep marginal revenue curve, okay? So we're going to be thinking about, where does that marginal revenue curve equal that marginal cost curve? That's the quantity that a monopolist would choose, right? So if we go ahead and look at that table, how do I know what my marginal revenue is? Well, marginal revenue is simply the change in total revenue. So here it's going up by 9,500, right? I would then take that and divide that by the change in the quantity, right? Change in total revenue from a change in quantity. That should give me my, marginal revenue. Now here, I could use Excel, or I can notice, oh, all these quantities are jumps of 100. Generally, I'll always give you the same increase in quantity. It might not always be 100, but in terms of like, it always goes up by 100 or always goes up by 10, etc. So I'm just going to go through and calculate the marginal revenue at every single one of these units. Okay. So now that I'm looking at this, okay, the marginal revenue of the first 100 units is greater than the marginal cost of 60, so I'll produce that. 200, right, that quantity, the marginal revenue is 85, greater than 60, greater than 60, greater than 60, not greater than 60, so they won't go from 400 to 500 units. They would stop here at 400. That's the last quantity where the marginal revenue is greater than or equal to the marginal cost. So even though we go up to the point where it's equal, when we have these examples that aren't truly continuous, right? I'm not giving you every quantity from 0 to 1200. You stop at the last quantity where marginal revenue is greater than or equal to marginal cost, right? So that would be at a quantity of 400. And then what's the corresponding price, or the point that we're at on the demand curve? So we just said this was 400. We would be at what point on the demand curve? At that price of 80, okay? So the firms would set a price of 80. Now here, it's how much is each firm producing. So when we have these duopoly market models where we're looking more at game theory, we said this is the total quantity they would be producing. I'll always kind of keep, I'm not going to give you like triopolies or quadopolies, right? It's just two firms. So they would evenly split, excuse me, whatever that total quantity of monopolists would choose in half. So here, if they hold true to the agreement, they would charge a price of 80, and each would be producing 200 units. Excuse me. Now, what if instead they break the agreement? So this is the idea that, okay, if I'm looking here, if we both hold true to this agreement, we know that there's 400 units in the market. The last person will be willing to pay $80. If I break the agreement, and I can think about it two ways. If I produce a higher quantity, I know that to convince the next 100 consumers, they're willing to pay a lower price. So the price in the market is going to go down if one of those firms decides to produce an additional 100 units. Now, the firm producing additional 100 units, they're making, selling 100 more units at $75. That's going to more than compensate for the fact that each unit they're selling from the first 200 they were producing, they're making $5 less. So the firm that produces more can increase their profits. But the firm that keeps on producing 200, they're still selling the same number of units, but now at a lower price, their profits would go down. So there was always this incentive to be the one firm that broke the agreement first. Or you can think about it in terms of price. If I lower the price, everyone was going to buy from me. And so there was always this incentive to be the one that kind of charged a lower price, which drove us down to that perfectly competitive quantity or that perfectly competitive market equilibrium, which would be where if this is the supply curve, right? Marginal cost represents supply is equal to demand. Where's the last unit where that demand curve is greater than or equal to 60? If we look at that table, that would be just the point I'm at in the demand curve. That's the price. So it would be at 800 units. So if they both break the agreement, we know that they're going to lower the price all the way down to their marginal cost, which would be 60. And if the total quantity in the market at 60 is 800, each firm would be producing 400 units. Okay. Now, one thing I'll throw into this, and I likely wouldn't ask it in terms of these duopoly models, but because we have a nice table here, if this was a monopolist, actually, I'll show you here first. If this was a monopolist, right, so we had this twice as steep marginal revenue curve, we said that whenever marginal revenue is positive for every quantity in this range, if marginal revenue is positive, that meant that we were on the elastic portion of our demand curve. Okay? Anytime we were at a quantity where marginal revenue was negative, there we're on the inelastic portion of our demand curve. So in general, whether or not it's a monopolist or two firms acting like a monopolist, if they can hold true to that agreement, they'll be operating on the elastic portion of the demand curve. Now, if they break that agreement, or we're looking at a perfectly competitive market, we generally think about where are we going to be at on that demand curve. It's going to be somewhere where marginal revenues are negative, or we're going to be on the inelastic portion of the demand curve. Okay. So that will kind of come into play if we're looking at some of the monopoly examples. If we have time, we might cover some. I'll kind of revisit this. But in case we don't, just depending on what people ask, I want to make sure we know that when we have positive marginal revenues, demand is elastic. Negative marginal revenues, it's inelastic. So even if I don't have the visual, let's say I just had this table. Well, anytime marginal revenue is positive, right, I know I'm on the elastic portion of the demand curve. As soon as my marginal revenue starts to become negative, now we're on that inelastic portion of the demand curve. Okay. So here, my drawing didn't quite line up with the table because even at that perfectly competitive outcome, we still were on the elastic portion of the demand curve. It won't always be the case that it's inelastic. I was just making this point that it could be, right? That when marginal revenue becomes negative, it could potentially be that we're on the inelastic portion of the demand curve. Right? There will be some point where it switches. In this example, it just happens to be that the marginal costs are high enough to where it would still be on the elastic portion. If instead the marginal cost was 40, well, now where's the perfectly competitive out quantity? Okay, it's down here. Now we're on the inelastic portion of the demand curve. Okay. All right. And so the next one, someone said something about question 1. So questions 1 and 2 might be a little bit easier, and I'll kind of add in some stuff that would maybe be a little more complicated. You could see, wink, wink, show up in the final. So if I'm telling you that the current price is $1, the firm is producing 100 units, and the average total cost is 3 at that point. So in this example, I would probably throw in a caveat. We're assuming here, okay, we're assuming that the firm is currently maximizing their profits. So we're not looking at a shutdown decision in these problems. I'll add in a question after we work through this with if I wanted to add in there the option of shutting down. But here we're just assuming that this firm, is operating at the profit maximizing point. What would the value of profits be? Well, this one should be a very easy question, because if I look at the current price and I look at the average total cost, how do we calculate profits if a firm is operating? Doesn't matter what type of model we were looking at. It was that difference between The price and average total cost times the quantity I'm producing. My per unit revenues, my per unit costs. Okay. So anytime price was above my average total cost, we know we had profits that were positive. This is kind of like scenario one. Okay. So my price was not above average total cost, right? We were told the price was 1, the average total cost was 3 at this quantity of 100. So I know I'm in this second scenario where anytime price is below average total cost, then my profits would be negative. Okay? And from there, it's just a matter of plugging in those values, right? So I had a quantity of 100, I had a price of 1, average total cost of 3, should give me profits of negative 200. Okay. So negative 200 would be my profits. Now, in the long run, what will my profits be? And what will happen moving from this current price, short run price of $1 to that long run? Well, we said profits are negative here. So I know that in the long run, what are some firms going to do? They're going to exit, right? As they exit this market, what's going to happen? Right? So this is where, and I'll kind of come back to this in a second, but to kind of give you an idea of two, just to be complete in our answer here. So we had this scenario, and we were thinking about, here's my average total cost, here's my marginal cost. And let's do demand, supply. So on the left, this is our market. On the right, here's our firm. So that current equilibrium price, which was $1. In a perfectly competitive market, that price represented the marginal revenue of the firm, right? So we were at a point where that was below our average total cost. So this area represented our kind of profits that were negative. Okay. So what's going to happen in the long run is that firms are going to, if there's negative profits, exit this market. As they exit, so this is where it's not a cumulative final, but it's comprehensive in that we're using things we talked about in previous modules. A smaller number of firms would mean we get a decrease in supply, which is going to push the price up. In the long run, we actually know what will that price be. Well, that price becomes the marginal revenue of the firm at that profit maximizing quantity. So here we can think about before firms were starting out here. After firms exit this market, the price will rise until there are no longer negative profits. Now there's no incentive for any firm to exit this market. And so in the long run, our profits will be exactly equal to 0. Right? So as long as we have free firm entry and exit, in the long run, profits will be 0. Okay. Now, some other questions I could ask that might be a little bit more difficult is, and it kind of weird, but notice what happened to the quantity in the market when these firms exited. Well, the quantity in the market actually went down. However, the quantity each firm produces goes up as firms exit. So you can kind of think about it this way. We're losing the entire production of one firm. So all the existing firms are going to pick up a little bit of that quantity, but not as much as we lost, right? So maybe the firm that shuts down, they were making 100 units before, now they're not. Now the remaining firms each produce, an additional unit or two. There's only 10 firms. We gain additional 20. So each firm is producing more, but overall we're still seeing kind of a loss in the market. Okay. Excuse me. All right. So let's think about an additional question I could ask in something like this that might be a little bit trickier. So probably won't be as simple as just calculating profits here. You probably would also be given an additional piece of information, because when you know profits are negative, well, here I'm assuming that this firm should be staying open, that they're in the long run, so their average total cost, if it's in the short run, that even though price is below average total cost, it must be above average variable. So let's think about a scenario where instead of just that information, I also told you what the average variable cost was. Okay, so we'll kind of go through this one first. So let's say my average variable cost was, what do we want? We'll start out here with it being equal to 2. Okay. So we've got two scenarios. In fact, here, I'll kind of color code this as red. So the first scenario would be if my price is ever below average variable cost, we said, what should this firm do? We know profits will be negative, but what they should actually do is shut down, making their profits simply negative, whatever the fixed costs are. Okay. So we'll work through a scenario where price of $1 is below the average variable cost. Okay. So instead of simply plugging in these values and finding, okay, yeah, my profits, if I stay open, we said it would just be that quantity times the difference between price and average total cost. So this would be 100 times 1 minus 3, or negative $200. Okay. What if instead, though, I decided to shut down? Well, there, I wasn't directly given my fixed costs, but if I gave you an example like this, you should be able to calculate what those profits would be if you shut down, right? So I might not tell you, maybe the question will just ask you, do they stay open or shut down? In which case, as long as price is below average variable cost, they should shut down. If price is ever above my average variable cost, well, there I know I should stay open, okay? So we're in this scenario where the price is below average variable cost. So what would my profits be if I shut down? Well, I can rewrite this as my average fixed cost times quantity. And then I can rewrite that as I wasn't given the average fixed, but I know that the average fixed is just the difference between my average total and my average variable costs. So notice here, I've got, kind of keep this separate here, negative, my average total costs were what? 3, average variable costs were 2, quantity was 100. Notice if I shut down here, my profits would be negative 100. That's better than if I stay open, I'd lose $200. Okay. So this would be kind of our first scenario, that if my price is below average variable cost, I should simply shut down because my profits there would actually be lower. Or, a lower negative value, sorry. It would be like a smaller loss. That's what I meant to say. Now, let's think about if we had a second scenario where price is above my average. So let's say my average variable cost, I guess I should have color coded this as blue. Let's say it was 0.5. Well, now the price is above that. It should be that I should stay open. Now, when I calculate my profits, if I shut down, they'll still be negative 100, right? Average variable costs, or sorry, not necessarily, because my average variable costs are changing. So if I've got my average variable costs here, right? Let's say instead they were 0.5. I know that it should be optimal for me to stay open. Well, I can kind of go through this. My profits from staying open don't change because it's just quantity times the difference between price and average total cost. So nothing there changed. 100 times 1 minus 3 would be negative 200. Okay. However, with these lower average variable costs, if I now calculate the profits of shutting down, what would they be? Well, it's negative difference between my average total and average variable cost times quantity. Average total was 3. Average variable was 0.5 times 100. Now, when price is below, or sorry, when price is above my average variable cost, now I'll notice if I shut down, my profits are actually losing $250 as opposed to if I stay open, I'd only lose 200. Whenever price is above average variable, we said we should stay open. Okay. So being able to make this shutdown decision in problems like this, and knowing that if I do in fact need to shut down, right? So if my price is not above my average variable cost, it's like the first scenario where it was below the average variable cost, I know then I'll shut down, and the way I calculate profits is simply finding what my fixed costs are, and then profits would be negative fixed costs. Okay. Any questions over anything there before we move to, I think it was problem 28. I'll go back and double check. Yeah, 28. Okay. All right. So yeah, this is a similar way that we would have to solve these models if we had these not these perfectly competitive markets, but we have monopolistically competitive markets. So this is very similar to the one that we just did, right? We're given a quantity. We're told at that quantity, marginal revenue is equal to marginal cost. So it must be the quantity that maximizes profits if we stay open. So if we stay open, how do we make that decision? Well, it's not whether or not price is above or below average total. So price here is below my average total. So I know profits will be negative. So I hopefully could rule out D right away. Oops, sorry. What I need to check to see if I stay open is my price above or below my average variable? Well, it's below the average variable. So that tells me I should shut down and my profits simply should be negative fixed costs. So it would actually be the exact same equation with just different values. So in this one, we had the price was like what, 38, average variable costs were 45. Okay. I think average total costs were 58, quantity was 10. So here, because my price is below the average variable cost, I know I should shut down. How do I calculate profits if I shut down? It's just negative whatever my fixed costs are. We said we rewrite that. That's the same as this. So quantity was 10, average variable cost was 45, average total was 58. So if I do the math here correctly in my head, should be profits of negative $130. All right. Now I can also prove this to myself if I have extra time. If I ever want to, I can always say, okay, well, what would my profits be if I stay open? So if I calculate what my profits would be if I stay open, no, 38. Here I would have what? Negative 200. So my profits from staying open would be worse than my profits if I shut down. Okay. $12. Okay. So we're thinking about a monopolist who is price discriminating. Which of the following would be true relative to when they set a single price? Okay. So I will actually, we got plenty of time. I'm going to go through this one kind of quick, 10 and 11, and then we'll kind of answer 12. It kind of all goes along with each other. And then we'll kind of go down to the later ones. So I can guarantee you, I will give you a problem like this where you have a demand equation, you have a constant marginal cost, and you're then asked about the quantity and price that a single price monopolist would set. Okay. So let's say we have this example where we've got this demand equation. So its price is equal to 100 minus 2Q, and the marginal cost was constant. What was that, 40? Yes, at 40. Okay. So what we're thinking about here is I've got this constant marginal cost at 40. I've got my demand curve, which starts at 100 and has this slope of negative 2. Okay. So if I'm a monopolist, I know that I make the decision, a single price monopolist, based off of a twice as steep marginal revenue. So what should the slope be? Negative 4. So if I ever have a problem like this and I'm trying to figure out where is that profit maximizing quantity, where marginal revenue is equal to marginal cost. So my steps would be 1, determine what my marginal revenue is. Okay. Marginal revenue will simply be start at the same point as my demand curve, but be twice as steep. Okay. So simply demand, but twice as steep. Okay. The next thing I'll do is set that marginal revenue equation equal to that constant marginal cost and solve for the quantity. Okay. So here marginal revenue being equal to marginal cost. That would be 100 minus 4Q, right? It was twice as steep, equal to that constant marginal cost. Well, now it's just a little bit of algebra. I subtract 40 from both sides. I add 4Q to both sides, and I get what? 60 is equal to 4Q. Divide both sides by, 4, and I get that profit maximizing quantity should be 15. Now, the way that it was written in the practice problems, I then give you an assumed true quantity, because if you got one wrong, you'd automatically get two wrong. Likely, we're going to combine those questions in the final. So I wouldn't give you an assumed true quantity. So this won't match up with the answer that's in problem 2, because we're going to use the correct quantity, which is 15. So once we have that correct quantity, we're going to plug that monopolist quantity back into our demand equation. So our demand equation was that the price is going to be equal to 100 minus 2Q. So we plug 15 into here, and we end up finding that the price, the point we're at on the demand curve, that the monopolist would charge would be 70. So we plug it in demand. Excuse me, if I can spell right, and then solve for that price the monopolist would set. Okay. So I can guarantee you I'm going to give you one like this, where I give you the demand curve and a constant marginal cost. You then have to either solve for that quantity that maximizes profits, or potentially, more likely, I'll ask you what that price they would set would be. Okay. And this is kind of the procedure, the steps you would follow. Okay. All right. So getting to question 3, thinking about price discrimination. If we have perfect price discrimination, they're not going to make the decision based off of this twice as steep marginal revenue curve. They're going to charge every consumer exactly how much they value that good. So our demand curve, if we can price discriminate, becomes our marginal revenue curve. So what quantity, this isn't the question in 3, but just for the sake, what quantity would the perfectly competitive firm choose? Or perfectly competitive? Yes, that will be the perfectly competitive point, but I didn't say that yet. So what quantity would the price discriminating monopolist choose? Wherever marginal revenue, or that demand curve, right? Because they're no longer facing the twice as steep marginal revenue curve. Their marginal revenue curve has become the demand curve. So it's where that demand curve is equal to the marginal cost. If it's a monopolist, marginal cost would represent supply. Okay, well, the point where supply is equal to demand, that's our not only the price discriminating quantity, that would be the perfectly competitive quantity as well. Okay, so all I would do there is set my demand curve equal to that constant marginal cost, and then solve for what that quantity would be. Okay. So if I do that in this example, I get what? So my demand curve was 100 minus 2Q, set that equal to my marginal cost of 40. A little bit of algebra here. And I get that quantity would be equal to 30. So the price discriminating monopolist will choose that perfectly competitive quantity, which will be higher than the single price monopolist did. All right. Now, question 3 asks a few more questions, which is comparing things like total surplus and consumer surplus. So if I'm thinking about, and here we can use constant marginal cost, we could actually have, kind of increasing marginal cost or supply curve as well. And we'll see the same thing happen. So what's the single price monopolist do? They set this quantity, and this price. So what is consumer surplus? Consumer surplus is the area below our demand curve, but above that price they're paying. So initially, this was the consumer surplus for a single price monopolist. Where is producer surplus? It's the area below price, but above their supply curve. So here was our producer surplus. Total surplus is just the sum of those two. So we said, with a single price monopolist, what are we doing? Well, we're not seeing, remember, the perfectly competitive quantity was the allocated efficient quantity or where total surplus is maximized. So total surplus is maximized out here, right? So what surplus are we missing out on? That difference between our supply and demand curve for all of these units that the single price monopolist isn't producing, we would generate some deadweight loss. Okay. Right. So if we wanted to compare this to if they're price discriminating, we said for the price discriminating monopolist, this isn't their marginal revenue curve. Their marginal revenue curve simply becomes demand. So what is consumer surplus? Well, consumer surplus was taking at every single quantity the difference between the price or the demand curve, no, sorry, the price and the consumer's marginal benefits or the demand curve. Well, if I'm charging every single consumer exactly how much their marginal benefit is, the difference between the price and the marginal benefit for every consumer would be 0. So consumer surplus for a price discriminating monopolist goes to 0. What is producer surplus? Well, producer surplus is adding up for every quantity the difference between the price they're charging, right? That's like the benefit. Sorry, I flipped these. Right, the marginal benefit. I was thinking producer surplus, and I was talking about consumer surplus. It's the difference between price and marginal benefit. The same thing applies, though. The difference will be 0. So for producers, price is a good thing. Marginal cost or the supply curve would be, the bad thing. So we would add up the difference. Well, if I'm charging every consumer different prices, the difference between that supply and demand curve, all of this would be producer surplus. Notice I no longer have any deadweight loss because the price discriminating monopolist gets to that perfectly competitive quantity. It's just that all of surplus is now producer surplus. So when we can price discriminate, and this is where just kind of intuitively, if I can charge everyone different prices, that's better for the producer, worse for the consumer. In fact, not only does consumer surplus go down, if it's perfect price discrimination, we said it would go all the way down to 0, but we've actually increased total surplus and eliminated some deadweight loss. But, this gets to be a more nuanced argument than probably we've had in this class, but right, just because total surplus is maximized, I think that, and it gets more complicated to model, but we probably don't value producer surplus in society the same way as we do for consumers, right? We generally want to protect consumers more than producers. But if we're just trying to understand what's happening, total surplus is still maximized. Producer surplus is going to be all of that total surplus, but we have eliminated some deadweight loss. Okay, so if we're thinking about in problem 3, oh wait, it wasn't problem 3. What problem was it? Problem 9. Sorry, this was we were thinking about problem 9 here. What did I do? I went back to no. I just did problems 10, 11 for you. The question originally was for problem 12. Am I correct? Yes. Okay, 12, and then we'll go to 21 and 22. So which of the following is not true about a price discriminating monopolist? Producer surplus will be higher. We said total surplus will also be higher. We will also decrease deadweight loss, but consumer surplus doesn't increase. It goes to 0 or it decreases. So the one that's not true there would be 12. Okay. Or sorry, the one that's not true there for 12 would be D. Okay. All right. Any other questions on those before we jump to 21 and 22? So 21. Okay, so some game theory stuff. So this is good. So I like to solve these. I mean, I can talk through it, but I think if you had this in front of you, I would probably rewrite these myself if I was taking the exam. So we had firm 1, they can advertise or not advertise, and we had the corresponding kind of payoffs. So we can just write all of these down. So I will always kind of keep this the same, and I'll put in some like stuff in parentheses on the final, where I always put firm 1's payoffs on the left and firm 2's payoffs on the right. So that's the same if it's an extensive form game or if it's a normal form game. Okay. So here we've got what? 400, 400, 500, 300, and there's millions here, but right, that's just moving the decimal, so we don't have to worry about that. Okay. So we're asked what's true in this game above. We're thinking about dominant strategies, Nash equilibrium, etc. So the way that I would go through and solve this game is for person two, their payoffs are on the right. So if person one chooses to advertise, right, that's one of their possible choices. What should person two do? Well, if they advertise, they get 400. If they don't, they get 100. So they would choose to advertise. What if person one chooses not to advertise? Well, person two, if they advertise 300, not advertise 400. Right? So here, we've got person two's best responses to both of person one's possible choices. If I'm instead thinking about person two, right, making the choice to advertise, what should person one do? Well, 500 is greater than 400, so they won't advertise. What if person two is not advertising? Well, 700 is greater than 400, so they would choose to advertise. So notice in this example, first of all, person two changes what they're doing depending on what person one does, and person one changes what they're doing depending on what person two does. So we don't have any dominant strategies, right? They'll change their decision dependent on what the other person does. Non-technical way of remembering this, but there's no two well, it's not necessarily non-technical, but it's a less technical way of saying it. There's no two circles in the same box, or there's no combination of strategies here where if I changed my decision, I couldn't be better off. So let's say we were here. Well, if person two changes their decision, right, they're worse off. But if person one changes their decision, they're better off. And then if we're here, person two could change their decision to be better off. There's no place where both of us are best responding to each other's best response. Sorry, my lights cut out. They still got the summer energy savings going on here. So we have zero equilibrium here, right? There's no box that has two circles in it. There's no place where we're both best responding to each other's best response. So we would have no equilibrium in this game above. Okay. We didn't have any dominant strategies, so both players definitely don't have a dominant strategy if neither one does. There aren't multiple equilibrium. There's zero equilibrium, and we wouldn't just have one equilibrium here if there's none. Okay. All right. And then how would I think about instead if I had an extensive form game? Okay. So that's how we would kind of go through and solve one of these normal form games. So I'm going to write this out real quick. Wish I had like more of a interactive screen. So quantities 40, 30, firm 2, firm 2. And then we had, they could do what? 40, 30, produce 40, produce 30. And the payoffs were 250, 250, 400, 300, 300, 400, 350, 350. So if we have an extensive form game, the way that we're going to solve these is whoever is making the choice second, so that's the person here, right? Person making the decision first is always on top. If firm one is choosing this low quantity, right, 30 instead of 40, what is firm two's best response? Well, if they produce 40, once again, player two's payoff's always on the right. 400 is greater than 350, so they would choose to produce a higher quantity. If firm one is choosing the other option to produce a higher quantity, what should firm two do? Well, if they produce 30, they get 300, 40 only 250, they should also be producing a low quantity, or they shouldn't also, but they will choose to produce a low quantity here as well. So once we've decided what firm two's best responses are to both of firm one's possible choices, well, notice here, they produce different quantities depending on what firm one does. So we would say they don't have a dominant strategy in this example either. If in both scenarios they chose to produce 40, then we would say firm two has a dominant strategy. Right? It doesn't matter what firm one does. firm 2 always does the same thing. That's not the case in this example. So the way that I would solve these is once you determine the best responses of firm 2 to both of firm 1's choices, you know that if firm 1 chooses a high quantity, firm 2 will never do this. And if firm 1 chooses a low quantity, firm 2 would never do this. So when firm 1 is making the decision, they know all these payoffs. They know the incentives that exist for firm 2. They know that if they produce 30 units, firm 2 will always produce 40, and their payoffs would be 300. They know that if they produce 40, firm 2 will produce 30, and firm 1's payoffs would be 400. Which is better? 400. So the best response for firm 1 would be to produce this higher quantity. What is our equilibrium? It's not in the same box now, but like 2 circles on the same branch of this extensive form game tree. Firm 1 will produce 40 units. Firm 2 would produce 30 units. Okay. So that would be firm 1 produces 40. Firm 2 is going to produce 30 units there. Okay. Excuse me. Any questions on that one before we keep moving? All right. Now someone put in, was it 25? Yes. So we'll come down here. Yes, we're thinking about markups and excess capacity. The markup we said is always just going to be the difference between our price and our marginal cost. Right? So the markup, I think, is an easier one. So if I'm thinking about this example, where does the monopolistically competitive firm choose to maximize profits? It looks very similar to a monopolist. It's where marginal revenue is equal to marginal cost. So that'd be quantity of 3.5. The marginal cost at that quantity, the point I'm at in the marginal cost curve is what? 4. They go up to the demand curve to set the price, so 17. So my markup is simply the difference between that price and the marginal cost of the firm. So this example would be what? 13. So that's where that comes from. Now, excess capacity, we said what we're doing there is comparing the quantity that the firm is producing to the lowest possible per unit cost. So that's going to be that minimum point of our average total cost curve. So we know that in the long run, if this was a perfectly competitive market, we drew it out earlier today, we had a horizontal demand curve, and we said profits would be firms would enter and exit until profits were 0, which would be when the price exactly hits the marginal cost at that minimum point of the average total cost. That's like our efficient scale of production. So our excess capacity would be the units that the monopolistically competitive firm is not producing, where if they did produce them, they would be lowering the per unit costs. So our excess capacity here would be the difference between the quantity they choose of 3.5 and that lowest possible point in the average total cost curve, which would be 6. 6 minus 3.5 gives us that excess capacity of 2.5. Okay. All right. So if we're thinking about single price monopolist, consumer surplus compared to the allocated efficient point, consumer surplus would be higher or lower. Okay. So if I was thinking about this depiction of a single price monopolist, okay, what is the profit maximizing price and quantity of this single, or actually, sorry, wait, what question did you guys ask? No, I'm already, 14, not 16. Okay. So 14, it's a single price monopolist. So they would choose the profit maximizing quantity where marginal revenue is equal to marginal cost. They then go up to the demand curve to set the price. Okay. So at this price, right, what would consumer surplus be? Well, that's just the difference between the demand curve or consumers' marginal benefits and the price that they're paying. So consumer surplus would be this triangle here. So once again, not cumulative, but comprehensive. We need to know how to find consumer surplus. It's the difference between the consumer's marginal benefits or the demand curve and the consumer's marginal cost, which is this price. So consumer surplus would be what? This triangle. So 40 times 20 times a half. So 800 times a half would be 400. Now, if I had given you multiple options where 400 was a potential answer, well, relative to the allocative efficient point, what would happen? Would consumer surplus be higher or lower? If I was at the allocative efficient point, let's say this market was operating where if I have a monopolist, what is their marginal cost? That's simply supply. Right? Supply represented the marginal cost of all firms, but if we only have one firm, the marginal cost of that firm is the supply curve. So the supply curve is equal to the demand curve out here at this quantity of 30. If this was an allocatively efficient market, kind of can think about this as another word for a perfectly competitive market, well then, what would the price be? 40. So consumer surplus would be the area above that price, but below consumer's marginal benefit or below the demand curve. So consumer surplus, if this was an allocated efficient market, would be this entire triangle. Now, visually, you can see that that includes the consumer surplus from a monopolist plus more. But if we calculate it, it'd be what? 60 times 30. So what? 1,800 times that half, so 900. 900 would be consumer surplus of the allocated efficient market. We just said the consumer surplus, if it's a price discriminated, if it's a single price monopolist, would be 400. That's lower, right? So compared to when the market is at the allocated efficient point, that consumer surplus of 400 will be lower than consumer surplus, which we just said would be what? 900 if we were at that allocated efficient point. Okay. So that was 14. One other thing I'll make a point to here. If I'm calculating deadweight loss is always going to be relative to the allocative efficient point. So the allocative efficient point would be here. Total surplus would be the area in between the demand curve or the marginal benefits in the market and the marginal cost. So here I wouldn't ask you to calculate it because we have like some curvature to our marginal cost curve, but it would be this entire area. If this is a single price monopolist, what surplus are we missing out on? Well, every unit from 20 to 30, we're no longer seeing the monopolist produce those units. So the difference between the demand curve or the marginal benefits in the market and the marginal cost of the market, this triangle here would represent our deadweight loss, right? So if we wanted to calculate deadweight loss here, it'd be what? 60 minus 20, so 40 times 30 minus 20, so 40 times 10, and it's a triangle, so times a half, so that would be a deadweight loss of 200. Okay. Now, if we wanted to regulate this market, so I think that's question 15, how could I reduce deadweight loss as much as possible? So my initial instinct might be, oh, I would just set the price, right? I could use a price ceiling, set the price at that allocatively efficient price. Now I've got to the allocated efficient quantity. Okay, excuse me, I've eliminated deadweight loss completely. What's the problem with doing that? If this firm, right, this was a monopoly depiction. So if I am charging $40 for the monopolist, is that above or below their average total cost? Below. So their profits would be what? Negative. What will they do in the long run? Exit the market. If it's a monopolist and they exit, how many firms are left? 0. We would lose the entire market. All of this would be deadweight loss. So we can't lower the price. If it is a natural monopoly, we can't actually get to that allocated efficient point. So what can I do to minimize deadweight loss? I can lower the price until the profits of the monopolist are equal to 0. Now they're indifferent about staying in the market or not, so they won't exit the market. And if I lower the price to 50, well, now they're going to produce 25 units. Okay, deadweight loss wouldn't be this entire area. Now it's only going to be this little triangle. So I've minimized deadweight loss, but if I had a natural monopoly, I may not be able to completely eliminate it. Okay. Where are we at for time? 20 minutes here. All right. Any other questions people have? So there is one thing that I want to mention here that we kind of already talked about. So if I had a single price monopolist, I can only regulate them down to this point where I'm at price of 50, I still have some deadweight loss. What's interesting though, is when I'm looking at like that profit equation and the difference between price and average total cost, that only applies to if I'm charging a single price. So whether or not that's a monopoly setting a single price or the government, that's how we're calculating profits. If I'm thinking about if they can price discriminate, how much money is being made off of every unit? Well, if I can charge consumers exactly what their marginal benefit is, every unit, the profit made would be the difference between the price they're charging and their marginal cost. So the difference between the demand curve and the marginal cost, that would be the profit earned on every single unit. So a price discriminating monopolist, we said, would get out to this point that would be allocatively efficient. So a price discriminating monopolist will actually go past that point of regulation because they can charge different prices to every single consumer. So we end up at that allocated efficient quantity. The only problem is, even though we've eliminated deadweight loss, what did we say we do to consumer surplus? Well, now it's equal to zero. So, we have this, the government kind of, what their role should be is to weigh out, okay, yeah, we can eliminate deadweight loss, right? But if consumer surplus is zero, that might not be the best thing for society either, right? And so even if we have a price discriminating monopolist, right, even though they get to that point where deadweight loss is eliminated, maybe we actually don't want that, because that's also, if they're price discriminating, purposely price discriminating, we also have consumer surplus of zero. Yeah, so the final exam is just the last 4 modules, right? Now, these modules, we're using some of the other things like demand shifts, we're talking about elasticity, but in terms of like the material covered, it's just 10, 11, 12, and 13 are the modules on that exam. Hopefully you can kind of pick up on that from this practice fund. Yep. I think that was the question. Yeah, yep. So it's not cumulative, but it's comprehensive in that I'm expecting you still, are familiar, and we're still using some of the old stuff we talked about, but I'm not asking you the type of questions you would have seen from modules 1, 5, etc. Yep. All right. So for those of you who are here live or choose to watch this video, there's one kind of like 29. And I'll work through it, maybe one that's even a little more complicated than this. I want to talk a little bit about monopolistically competitive markets and some things that, wink, wink, I know might pop up on the final exam. So let's assume we had this example where firms are choosing to advertise. So what is that going to do? It's going to increase their fixed costs, right? Because no matter how many they sell, they spent the same amount of money on advertising. So it's not tied to quantity. So we can think of advertising will increase our fixed costs. And hopefully, as a result, it increases the demand for our product, right? That's the whole goal. So to think about the impacts that this is going to have, right? Instead of drawing these all out at once, I'm going to draw the impact of both of these things and then think about the total effect. Okay. So let's say I have a monopolistically competitive market, and we'll start out. So here's my average total costs. Here's my demand curve. Marginal cost curve hits average total cost at its minimum point. And then here's my marginal revenue curve. Right? So where would the profit maximizing price and quantity be before advertising? So here's my quantity, where marginal cost is equal to marginal revenue. Go up to the demand curve to set that price. Right? Notice, if I was to calculate the markup, what is our markup? It's the difference between price and marginal cost. So I would kind of have my markup as well. Now, I started out in a scenario to kind of make this point where profits are exactly equal to zero. You could draw this similar. You could do the same thing if you start out with positive or negative profits. I'm just going to start out with profits or zero to really kind of make this point. So price is equal to average total cost. So we start out with initial profits at zero. Okay. If I've increased my fixed costs, that doesn't change my marginal cost. It's just going to change my average total cost. So I could think about I've increased my average total cost curve. So just the money spent for advertising, what does it do? Well, if it doesn't change my marginal costs, I keep choosing the same quantity. So the fact that we saw an increase in our fixed costs, this is if it just influences my average total cost, doesn't change my marginal cost at all. Quantity stays the same. Price stays the same. In fact, my markup doesn't change. But what does change is now that price is below my average total cost. So now my profits will be what? Negative, or they started at zero. I can kind of see from there that that decreased my profits. Okay. Now, if I'm thinking about what would the total effect of this advertisement be, so this is, I think, the 29, it was like talking about a celebrity endorsement. So maybe I wouldn't even have a change in costs, right? I think that one I even shut that down. But here, I've spent money, hopefully, to get the increase in the demand for my product. So what would that look like? Okay. So if I have a scenario, and let's say, I'll try to draw this pretty similar. So here's my average total cost. Right? Here's my initial demand curve. Here's my marginal cost, hits average total at its minimum point. And then I want my marginal revenue to be twice as steep, right? So if I started out, try to draw this pretty similar to the initial scenario. Okay. I've got profits being equal to zero. If I am able to increase the amount of demand that I have for my product, so I haven't changed the slope, there's still the same number of available substitutes, but I've increased the demand, which inherently would increase that marginal revenue for my product. What's going to happen? Well, the marginal revenue will equal the marginal cost now at a higher quantity. I'm going to go up here. Set a higher price. Okay. But now if I'm just trying to understand the effects of that demand increase, so I'm not changing my cost, I'm just shifting demand. What did that demand increase do to my profits? Well, now price is way above my average total cost. So I've seen that this demand increase, increased quantity, increased price, and increased our profits. Okay. Now, what did it do to our markup? It might not be as clear with my visual here, but that difference between price and marginal cost should be larger. We kind of went through that yesterday. In fact, I'll do another example here in just a second where we have a demand decrease to think about why it's changing that markup. So anytime you have a demand increase, that's going to basically increase everything, right? It's going to increase the quantity the monopolistic competitive firm chooses, the price, the markup, and their profits. So if I'm thinking about the total effect of spending this amount of money on advertising to get that increase in demand, well, what would my total effect be? Well, both of these things are happening. I'm increasing my fixed cost in order to increase demand. What's going to happen to quantity? If this doesn't change quantity, this increases it. Quantity would go up. If it doesn't change the price, but it increases it over here, price would also go up. My markup in both scenarios, all right, doesn't change, goes up. So technically here I could think about my markup is also going to go up. What's happening to profits though? Oh, well, they're pushing profits in different direction. So this is one of our economics answers where it's indeterminate. We don't know without any additional information, excuse me, what's going to happen to our profits if we had this example where we're spending a certain amount of money on advertising and we're getting this increase in demand. Okay. All right. So I could change this example a little bit to where we had something that, maybe I spend all this money on advertising, or I don't know, something happens where I've spent this money and I get like a backlash to it. And so I actually see a demand decrease. So to kind of make this point, it works in both directions. So let's say I've got my average total cost curve. I'm going to start out, here's my demand. Here's my initial marginal revenue, right? And I wanted this point, so here's my marginal costs. Well, I'm a little bit off here, but doesn't matter. So here's my initial price. Here's my initial quantity. Here would be kind of like my marginal cost. So there's my markup, right? Profits start out at 0, right? I'll draw this very extreme to kind of make this point, but let's say I had this decrease in demand. So now I'm down. I'm going to try to draw this parallel. So here's my decrease in demand. Here's my decrease in marginal revenue. So here's my second demand curve. Here's my second marginal revenue curve. If I saw a decrease in demand, that's going to decrease the quantity the firm chooses. Notice this is pretty close. It's also going to decrease the price. And then what's happened to that gap in between price and marginal cost? Well, it started out here. It should also then decrease that markup we see. And if I start out at 0 profits, now what's going to be true? Price is way below average total cost. This would decrease my profits as well. So I can kind of work in either direction, thinking about things that increase the overall amount of demand that a firm gets versus things that would decrease it. Everything just works in the exact opposite direction. Okay. All right. Any other questions people wanted to see kind of covered here? Let me think. Which ones haven't we done? So this might be worth talking about something like 7 and 8, but I'll add in something that I think might be good. So let's say I currently had this equilibrium price of 375. So in the short run, if I'm thinking about where that would be, looks like it's like right here. In a perfectly competitive market, the price is our marginal revenue curve. So if our marginal revenue is 375, that hits marginal cost, it looks like here at a quantity of 325. So at 325 units, that's the profit maximizing quantity. That price is 375. Price is above average total cost. So my profits there should be positive, right? So 325 and positive. Okay. Now, in the long run, what's going to happen? If I have positive profits, what are firms going to do? Right? So if I've got positive profits, firms will enter that market. Okay. So this is where we'll think about, read questions carefully. And on the exam, I've typically bolded things to kind of make sure that we're paying kind of closer attention to certain things. So if I've got my initial supply and demand in the market, here's that initial equilibrium price. That's the firm's marginal revenue, right? So let's say I've got my firm's marginal costs. And let's say we start out in this scenario where profits are equal to 0. They're at that minimum point of the average total cost curve, right? And this doesn't matter if we had negative profit. I should have drawn in positive profits here, but since I've already got it for the sake of time, let's just assume that, like in that previous one, if we had positive, let's assume that even if there weren't positive profits, for some reason firms enter this market. What's going to happen? That's going to increase our supply curve. As the supply curve increases, what happens to the price? It goes down. Well, that price is the marginal revenue of the firm. So notice, initially, the market quantity was here, and the firm's quantity was right here. So on our right, we've got the firm depicted, and over here, this was the market. Okay. After more firms enter the market, we see the overall quantity in the market goes up, but what happens to the quantity of each firm? Well, now marginal revenue is equal to marginal cost at a lower quantity. So as firms enter, it pushes the price down. It's actually going to decrease the quantity each firm produces, even though there's a higher number of firms. And now in this scenario, I start out with zero profits. Now what has happened to profits? They've become negative. So it's decreased our total profits. Or what a more realistic scenario is, why would firms join this market if profits were zero? If we had positive profits, firms join until that price gets driven down to where profits are zero. And now that would be our long run equilibrium. So firms will enter this market until the price hits 300. At that price, marginal revenue is equal to the price or marginal cost, which is equal to the average total cost. We're at the minimum point. Everything is equal in the long run for these perfectly competitive markets. Profits are zero. And so if I'm thinking about in the long run, the equilibrium quantity, we know that in a perfectly competitive market, the price will always get driven down to this minimum point of the average total cost curve, which is 300. And if we're thinking about our average variable cost curve, it wouldn't be that I look at that quantity of 300 and say, oh, here's my average variable cost. Because in the long run, what's true? Everything is variable. So there is no difference between average total and average variable costs. So in the long run, the average variable cost curve, like I have things like in building size, which are fixed in the short run, I can change in the long run. So my average variable cost curve kind of gets eliminated, matches up exactly with my average total cost. So in the long run, whatever point I'm at on the average total cost curve, so at a value of 300, that will also be my average variable cost in the long run. Okay. All right. So a couple more minutes here. Any logistical questions or any other questions about the end of the course or the final exam that haven't been answered here? We got through a pretty good amount of these questions. We worked through some more of the monopolistic competitive stuff yesterday. I would, once again, if you're feeling comfortable with the practice final questions, some additional good practice, 13 is the stuff we've done most recently. So it kind of depends on the individual. Like if you've forgotten some of the older stuff, maybe it's best to kind of go back and review that first. But if the newer stuff, you just haven't had as much experience with it and it seems a little bit harder, then maybe start with that. Or if there's, something that specifically a module that gave you troubles, I would kind of go back and start with those practice problems after I work through this practice final exam. Okay. So that'll be set to release the exam tomorrow at 10:30 a.m. open till 3:30 p.m. The usual kind of end or a little bit past the usual end of class. We usually end at 3:15. I will be available during that time. If you have any issues, please let me know immediately and we'll try to work on anything technical. Hopefully nothing happens. Like I said, exam 2 went pretty well. Don't want to jinx myself here. So hopefully the final, we don't run into any other unexpected issues. Okay. All right. So if there aren't any other questions, kind of end the recording here.